The United States has reached a critical juncture in the nuclear renaissance. To secure the nation's energy future, the nuclear energy industry has produced more than a dozen advanced reactor designs. Soon, these reactors will power the AI revolution, strengthen national security, and provide electricity and heat for homes and industry. But first, reactor developers must prove their concepts by building reactor prototypes. Now, Idaho National Laboratory researchers are helping reactor developers bridge the gap between computer models and real-world nuclear reactors by replacing neutrons with light. This is Vibrant, Visual Benign Reactor as Analog for Nuclear Testing, a surrogate nuclear reactor powered not by neutrons, but by photons emitted from thousands of LEDs. When coupled with the Microreactor Automated Control System, or MACS, it mimics the behavior of a real reactor, offering a safe yet powerful tool for advancing reactor development. Vibrant's LEDs simulate reactor physics, with colors and intensities shifting as temperature and reactivity evolve. But this is more than a light show. It's a platform that allows researchers to test critical functions of next-generation reactors, like INL's Microreactor Applications Research Validation and Evaluation Reactor, or MARVEL, an 85-kilowatt microreactor under development at INL. INL researcher Tony Crawford designed and developed the Vibrant systems.
Behind me is the Vibrant system on the right. It's a light reactor. It replaces the neutronics in a real reactor with light physics. MACS is a hybrid, so the actual actuators are the same technology that's used in the MARVEL reactor. It's a motor, a gear head to reduce the speed so that you don't insert too much reactivity at once. It has limits. It has a scram mechanism, so if you release the electromagnet, it will shut down the reactor. The actual deployable MARVEL reactor software is being developed on this system or will be beta tested on this system. Ben Baker and Andrew Heim are doing that currently. A lot of the hardware is being led by John Gray. So we essentially calibrate this surrogate reactor to act like the real reactor, and it has enough tunability to be able to do that.
By removing radiation hazards, researchers can observe and tinker with real-world reactor components unobstructed, refining designs in real time. This agile testing method has already led to critical improvements to the hardware of MARVEL's control systems. Vibrant and MACS also integrate advanced nuclear models like INL's Multi-Physics Object-Oriented Simulation Environment, or MOOS, which allows researchers to fine-tune software and explore innovative control strategies such as autonomous reactor operation. Beyond MARVEL, MACS and Vibrant can be calibrated to replicate the behavior of a wide range of reactors. This flexibility means there's no need for companies to start from scratch when it's time to test and refine control systems for the next generation of advanced reactors. By combining light physics, cutting-edge modeling, and real-world hardware, MACS and Vibrant are paving the way for safer, smarter, and more efficient nuclear reactors.